this is a review of our study of light up to date. And so what I'm going to do is I'm going to go through some slides that are sheets from our textbook and then worksheets that students have completed. And these are the things that you will be responsible for the assessment. Okay, so the first two pages that we studied were pages 2 and 3 in your light textbook. And they look as such here. And what they are is they are a picture in which has a lot of images in which there's artificial and natural light. And so what you are responsible for is being able to identify the difference between artificial and natural light and being able to list different types of natural and artificial light, similar to what we did here. This is 10 sources of light, and then 5 sources of natural light and 5 sources of artificial light. Few points to remember: the moon is not a source of light but a giant mirror that reflects sunlight. The fire in the picture can be argued to be either the natural or artificial categories, and I go back to here. This was a debate that people had. Fire can be man-made, but it also can happen naturally, so it does truly fit in both categories. In this situation, you could probably make an argument for artificial, as it is in a fireplace, which usually is man-made. The other thing you want to watch out for is candles, because candles are not electronic, and sometimes students associate electronic things with artificial light, but candles are a technology that is man-made. The next thing that we went into is how light travels. We did this experiment right here, and we talked about the definition of ray and beam, and those are two things that you should know. A single ray of light travels in a straight line. That's what we need to know, and that light travels in a straight line. This is the note that we wrote with the lesson. Light shines in beams, rays always travel in a straight line. I know this because when I shone a light through the 2 pinholes, it only made it through the holes when it was lined up in a straight line. This was accompanied by a diagram, which is done correctly here. You have the flashlight right there, the beam of light traveling a straight line, and it's only passing through the holes when the holes are lined up. Again, this was an extension to that work on how light on artificial and natural light. Why I bring this to attention is not because these are the correct answers. There could be multiple answers to questions like this. However, on assessments in all subjects, and especially science, these are great examples of supporting explanations of a belief. So the student here has decided one way or another. Yes, I think they are using too much artificial light, but more importantly, what they have done is they've backed up their belief with a reasoning that shows a logical thought process. And this is important because in grade 4, when you're answering questions like this, there's expected an explanation of your thought. So to justify yes or no answers, not just words like because I think so, but answers like yes, I think they are using too much artificial light. I think they're using too much artificial light because they don't have many sources of natural light. Their only source of natural light is fire. That is an excellent example of a supporting answer. Okay, reflecting light, and this part highlighted is something that you might want to pay attention to. And in our lesson on reflecting light, we made this diagram. Some important notes: the angle coming in is the angle of incidence and the angle of reflection. And this is a well done diagram in which everything's labeled clearly and the lines are drawn straight. However, the only thing that I would suggest to change is that the point of contact where the light ray exits the mirror is touching where it contacts the mirror. So this should be a V more so than it hitting, moving across, and then leaving. So it should look more so like that. But they've correctly drawn the light ray and the bouncing off onto the sheet just like we did in the experiment. Here are some things that you need. You should have the sheet in your book, which it was handed out to you. And these are important lessons that we've learned about how light reflects. Number one, a mirror is anything that reflects light so that an image can be seen on it. Therefore, a moon can be a mirror. A reflector can be a smooth or rough, shiny or dull surface. Okay, it doesn't have to be just what we have thought of as mirrors or windows. When light hits a mirror straight on, it bounces straight back. When light hits a mirror on an angle, it bounces off on an angle. So again, to those terms, angle of reflection, angle of incidence. And the approaching angle of light equals the reflecting angle of light. So again, if a light comes in on that angle, it's going to leave on the same angle if it hits a mirror. Let's just make this a mirror right here. Pretend this is a mirror, this line. Okay. The angle that it comes in at right here is the angle that it will leave at. We did this exercise in applying those concepts of light reflecting on angles with this maze and using diagrams of mirrors. You should have this in your book, and you should be able to apply the concept of reflecting light because you might be asked to do something similar to this on the assessment. Okay, two terms that we studied was reflect and reflector. They are in the glossary. I suggest you go over the glossary in general and look at all the terms that we've studied. So go through lessons 1 on artificial natural light, on how light travels in a straight line, the reflecting light, the one on refraction 2, and go over all the definitions that are bolded throughout those pages. Good reflectors. Okay, I've highlighted some pertinent information here. And we did this, sorry, I think with good reflectors, yes, we did this experiment here. So as you can see in the far left column, the materials, we did red construction paper, black construction paper, yellow construction paper, wax paper, tin foil, and a mirror. We used those materials. We made predictions what would be the best reflectors and which would be the worst. We came to understand that black construction paper was the worst, and we learned furthermore that black doesn't reflect well, that it absorbs colors more so than anything else. We also found that the lighter the color was, the better it reflected. And finally, if it was light and shiny, the shinier it was, the better it reflected. So the best reflector was the mirror, which was light and very shiny, and the second best was tin foil. We applied these concepts to the creating of a helmet for a bicycle later on in that unit. And you should know for this that dark colors and dark dull colors particularly don't reflect light as well as brighter colors and shinier objects. And these are the pages in the book, pages that we read over together. Okay, to translucent, transparent, and opaque. You need to know the definitions of the three, that transparent objects let light completely through, translucent objects let light partially through, and opaque objects block light completely. What you have here is a transparent mirror, what looks like to be a translucent transparent window, translucent window, and I guess this is an opaque window or wall. I usually use the idea of a brick wall as being opaque, or the example of a brick wall. Okay, again, I've highlighted information that's important here. You should have this experiment in your science notebook that we did, in which we made predictions about what was going to be transparent, translucent, and opaque, and then our results. This was an extension of homework again. Again, although these answers are subjective, meaning that each student can have different answers, they're examples of a student using critical thinking to give a proper explanation. And these were the flipped homework in which students had to think about, if they were an architect, which would they make their kitchen, living room, and bathroom out of: transparent, translucent, and opaque walls. And here's an example. As an architect, I would make the bathroom walls opaque because the bathroom, you need the most privacy out of all the rooms. This would also mean that you need an electric light in the room. So it shows critical thinking. It justifies their explanation. So therefore, it would be a correct answer. A bend in the light. So this is when we started talking about refraction. Okay. And this was the experiment that we did here. Let's go in and out of water. You should have these pages done. Okay. These here. The thing you should know is also that with refraction, that light is traveling at two different speeds. At one speed it's traveling through the air, and then when it hits water, in this situation with these experiments that we were talking about here, that it slows down, and when it slows down it gets that bend. So it's traveling through two different mediums, okay? One through air, and then the second time in both of this experiment with the cup and the pencil and with the penny, then through water. And when it hits the water, the light slows down, causing it to bend, and therefore you see this distorted image of the pencil. The pencil looks larger and broken because of it. These are things that we studied, we wrote a note on, and the note should be in your books as well. I was looking for it there, but I just couldn't find it. I will post that as well. The other thing is that when we were looking at the penny, we did the experiment in which we put a penny in a cup and walked away until we couldn't see it, then filled that cup with water, and the water allowed us to again see the penny. It was an example of how light bends when it travels through water, and the bending allowed the light to actually hit the penny again, allowing our eyes to see it. So that proves that light can bend when it travels through two different substances. So in the case of this experiment, the substance was air and then water. And that is the definition of refraction when light bends. Those are the lessons that you are responsible for knowing for this assessment on Friday. Okay, there's not a lot of information. You should have these sheets here. I will also post the sheets, all of the sheets on Blackboard that you're responsible for having completed in your book. I will also be checking your books to make sure that you're up to date. If you have any questions, don't hesitate to email.